Grandparents died yet this summer.
They have not yet. So, a few things. First, there are many more donuts than there are people. You each have to at least eat 3, maybe 4 donuts before leaving.
I did my duty with 2 donuts.
You hit your daily limit with donuts?
That's my daily limit of donuts. I don't know, Krispy Kreme has a hard limit for me of 2 before the 3rd one just tastes like ash in my mouth.
That's what the coffee's for.
Black coffee. Just drink black coffee. Trust me, I guarantee you. It tastes like a Krispy Kreme. I got all of them.
Also, I'm sure you all have noticed my eldest daughter in the room with us. Her name's Jillian. You can call her Gigi. She's not shy at all and hopes that you all make her feel uncomfortable and talk to her.
Let's say she understands this cup. How are you doing? Not a friend's time.
She wants to skip a grade in math, and so she's working on math this summer, and we've both come to the conclusion that binge watching HBO and Netflix is far more entertaining than work plodding through a math book, so she's agreed for the duration of this class to attend with me and work on her math each morning.
What class are you working on?
It's that core curriculum stuff. She wants to be in calculus in her senior year, and right now she isn't going to hit that because her junior high didn't teach quick enough.
My son did IM3 over the summer last summer, and he was doing trig this summer because he was a freshman last year, and he wants to be able to do calc next year. So he's convinced me to do that and pay for that through. It's like Brigham Young or something like that, like some online class that you can do. Yeah, because I mean, without the Mormonism. I mean, no offense to any Mormons here, but it was not what I was just looking for trig and math things. But they do like the accreditation, and they have the testing that you can go to a proctored test.
That's in what that matches California's core stuff. Yeah, how much is that?
I think it was like 2 something, 225.
Yeah, was it worth it?
Well, I mean, you stopped complaining. That was cheap. to get a 15-year-old to stop complaining and do math during the summer, that is very, very cheap. Small presentation. Oh yeah. Just feel like whenever he comes out, he's like, I'm bored. I'm like, have you done your homework yet? It's like, so he doesn't say that anymore.
You should bounce it back.
Yeah, no, he totally does though. He totally does. He like comes out and I'm sitting there and I'm just like staring at the ceiling. It's like, so, you done yet? Can you start cooking? Oh my God.
My next announcement is that my youngest daughter, I only have 2 kids, was playing Minecraft on my computer, my laptop, and to hear her tell it, the cat jumped on her and sunk his claws into her, causing her to toss my laptop. And, well, I can't show you because I have too many cords hooked up, but I can see the upper half of my screen.
That sounds like a creeper reflex right there.
So I have to kind of look over here. And I'm looking into getting that repaired. It's a computer that was purchased by the university. So I need to see what the cost is to get it fixed through the university and if I've got funds to pay for that in my university account. And I don't know what the turnaround will be for that. So that's a bit of a hassle. I did start looking into a replacement computer that I'd just buy myself, and I just cannot bring myself to buy a Mac with that touch bar on it. Losing the escape key as a Vim user is just a bridge too far.
Oh, those glasses stinky.
Yeah, the 15-inch MacBook Pro that has that touch bar up top, they lose all the function keys, including the escape key.
Oh.
And so you can get a little picture of an escape key and you can touch it. But call me old school, but that kind of tactile feel of an actual key that I'm hitting constantly, it's, and I'm too set in my ways to remap it to some other key. And I actually do use my caps lock, so I wouldn't want to map anything to caps lock. Yeah, and Walter Lau in ITSS, I'm not sure what department exactly he's in. I had coincidentally, unfortunately, I had broken my screen last fall, and that was my fault. I had unplugged cords getting ready to go to campus, and I brought it down, and I had unplugged my power cord, but it had, rather than sitting off to the side, it had actually laid on top, and then I closed it on it, and it's shattered it that way. And they, through some miracle, they had basically my exact screen on a broken laptop that they were able to pull off and put onto mine. So I got a cost-free repair that time, and I'm a little bit, hat in my hand. I broke my laptop again. And I have to tell them I did it. I don't think they want to hear that my kid was playing Minecraft and broke it.
Yeah. Important question right here. Did she get all her experience that she could have lost in that creepy laptop?
Yeah. That's calm. I didn't yell. So another thing then is that I had, in the past, there was a period of a few semesters in the past where, primarily for my 111 class, I would broadcast my terminal, meaning this, and so that you could, as a 111 student, could open up a web page and watch what I'm typing. And that had it was surprising. I didn't think it'd be a big deal, but it ended up being really massively popular. Everyone just wanted to either look at their phone or look at their computer screen at what I'm doing. I don't know, maybe they'd have their own terminal open next to it or something. But it ended up being a really popular feature. And then the tools I was using were no longer being maintained, and something happened and it wasn't working any longer, and I never did try to figure that out. This weekend I did investigate the problem, and I found some different tools that accomplish virtually the same thing. So I thought that you all would help me test out to see if that functionality works. And maybe if you like it, I'll do it every day. So if I type run 111 here, now I think if you go to the course shell, I have this link here, see Todd type. If you hit that, do you see my screen? When I do an ls and you see an ls? So what I would like you to do is I would like you to get either 2 or 3 browser windows open with that. The mechanism through which this is doing this is slightly different. It's actually running a tmux instance for every connection. So I'm wondering if I get like 30 connections, basically 30 tmuxes running on my laptop, if that's going to make any significant difference. So if you all would get 2 or 3 browser windows open showing that, and then I can just see over the day if that ends up being an issue. Say that again? Oh, yeah. I'm testing CTOD type, so click on that link and just leave it up. Oh wow, that's good. It says 33 connections. You all are pulling through for me. I appreciate that. Doesn't seem to be causing any problems on my end, so this actually might work all right. Which also means that I should be able to look at my phone instead of my broken screen.
Smart.
Except it's really small. Alright. And let me see, does that do it for the announcements? I think that does it for the announcements. Oh, one more big announcement. How many do we have in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you came in late, please avail yourself of the goodies up front. The other thing is we will not meet tomorrow. Okay, I should have some work for you all to work on, and then tomorrow will just be a work day. I suppose if you come in, that's fine, but I will not be here, so you're welcome to stay home tomorrow. Right. And I'll put an announcement on that. So that'll be a virtual work day. The first part of the day I won't be available, but the second part of the day I should be available for Piazza questions and so forth. I can probably squeeze in answering some Piazza in the morning hours as well. It's just hit or miss on my availability. Right. So we kind of finished up the shell last week, and that takes us to Python. We are in week 4, day 1. Let me see by how many people have we done at least a little bit of work in Python. That's 4. How many people have done virtually nothing in Python? 1, 2, 3. Okay. If, depending on the platform you're on, Python 2, version 2 of Python 2.x was big for years and years and years, and then had, a long time ago at this point, been supplanted by version 3 of Python. There still is a chance that you will find resources on the web that are version 2. I don't think it's as much an issue now, but you might just do a slight sanity check on your Google searches to maybe type Python 3 just to make sure you're getting the right search results and not getting old Python 2 search results. Now, there's a huge amount of overlap. There's a huge amount in Python 2 that does work flawlessly in Python 3. There are some significant differences, though. So keep that in mind. As far as running version 2 versus version 3, I noticed on Vagrant here, it doesn't matter whether I type Python or type Python 3 without any spaces. I noticed in both I get version 3.x of Python. just be aware of what it shows you here. I do know on my Mac that if I type Python 3, then of course I get Python 3. Looks like I get a slightly newer version actually. However, if I just type Python on my Mac, I do get version 2. So be aware of that wherever it is that you're running Python.
So that's how something to do with Bash.
Hmm?
Does that have something to do with Bash? How it's set up?
It has to do with the distribution. I believe, let me see, if I come, yeah, on my Mac I have Homebrew installed, and it looks like I just have both versions installed, and I'm not sure why. So, let's see, let me go here. Log in. I have some notes here. These, of course, will be posted. And there, let's do it that way. All right. So Python is a scripting language, just the same as you can script in Shell, script in Python. Similar to Shell, anything you type at the Shell you can put into a script. Likewise with Python, anything you type here at the Python prompt you can also put into a script. It's interpreted, not compiled. And there's no separate compilation process like we have in C++. Python is one of the many, many languages that borrows its syntax from C. So that's great. Makes us very happy, as there are many, many things that we can do without thinking about it since they're so similar. I guess let me start with print. No semicolons. More about that in a minute. I'm getting there. Everything in Python is really well documented. It's what is called a doc string. So, for instance, print, it says here, is a built-in function. We can get documentation on that, and what I'm going to do is I'm going to let me. Okay, so we see this dot notation, which we should be very happy with given our C++ pedigree, where we have an object dot method. Same idea here, could be object dot data or object dot method. Virtually everything that exists in Python, including things that you create, have this idea of a doc string. We'll talk a little bit about how you can create your own doc string for the things you create. However, it's certainly there for everything that's built in. Now this will, let me actually do it this way. What this shows is literally a string. You'll note that all this stuff starts with a double quote, ends with a double quote, and you can see that there are new lines in here. Rather than looking at this string, it is much easier on the eyes to print out that string. So I would go ahead and in a print statement, I would say print the doc string for the print function. Note that I have 2 underscores there. And once I do that, then this goes ahead and shows a little bit of usage and a description of each of the arguments to the print function. we worked a lot with printf, the print formatted. There's that same kind of formatting in Python. The way you specify that is, I'm going to actually put it inside a print statement. You have some sort of format string. Actually, let me do it without the print. You have some sort of format string here, and then a %, and then so that's what that looks like. It's a little bit foreign at first. However, once you start using it, it becomes very, very intuitive. Let me provide an example of that. So I can say the number %05D is assigned to a %S and now I can provide a number and I can provide a string. And so you can see this behaves exactly like printf does. So this provides a string. This is printing an integer in a field 5 wide, padded with zeros. So that's exactly what we get here. And then the %S is replaced by this string here. Typing, the typing's kind of dynamic. It's not, you don't have to assign the type at, well, to compile time, I guess would be the C++ term for it. I can simply say that a num is equal to 32, a string, these are obviously just names I just came up with, and now I can change this string to be, put these variables here. Is anyone looking at their little web page thingy? Is that actually more convenient than looking up? Oh, good.
Is there a way to, I noticed that it converted from hex to decimal. Is there a way to like force it to print it as hex?
What I would do is I'd type printf hexadecimal. %x. So if I come here and I type %x15, that's it. So where you quite frequently, I just have these strings just like this. You would obviously quite frequently have these things inside of a print statement. Oops. I noticed here that I started to try to use Vim bindings on this, and that did not work. I have it set up on my Mac, but not on this Vagrant box, so let me actually pause for just a moment and talk about that. There is a library function called readline. Where am I going to have it? Let me come here, see if it's in Vagrant. It is. All right. So you'll notice that it's in section 3. So this is something you can put with your code. Readline reads a line from the terminal and returns it using prompt as a prompt. Obviously, that in and of itself isn't much more useful than like getLine in C++. Where it becomes very useful is this paragraph right here. Read line offers editing capabilities while the user is entering the line. By default, the line editing commands are similar to those of Emacs. A VI style line editing interface is also available. Okay? So, when I am here at my bash prompt and I hit escape, K, and I'm going up to previous commands and then L and then CW to change word, what bash is using is it's using that readline function. And what I've done is I've set the option for VI bindings. Now readline reads configuration information. Let me come back to this man page. Yeah, what does that say up there? Readline is customized by putting commands in an initialization file, the input RC file. So it's default, just like all these configuration files. It's normally in your home directory and starts with a period, vim RC, bash RC, input RC, right? If I look here on my Mac, that is going to help you with the vim editing. There's another one, set key. I want to say that's not quite right. I actually thought I had it on my Mac here. I'm not sure. Let me type vim RC. Let's see, input RC vim. Yeah, that's the second one. I think, if memory serves, one of these is for insert mode and one is for command mode. So you'd want both of those in your input RC. Let me throw that in there. And now let me come back to here. That might be great. Now, let me see if that does anything for me. If I type Python, now I've got all my vim bindings here. Even though it's like fully documented and stuff, there's a little bit of hesitancy in my part thinking it's not going to work. All right, what did I ever doubt? So there's that. Let me see, where am I now? Let me come back here. Let me close that. All right. So we have include statements in C and C++. The very rough equivalent would be what I have here in these notes on line 4 there, the import random. So there's a library for dealing with random numbers, and if I say import random, that then allows me to use the facilities of that library or module. What you normally have to do is you have to, given what I did with that import statement, that would be the name of that particular module, and then following it would be the particular functionality I want to use. I want to take this moment to point out this dir, which gives you a list of things that you can do, in my example, with thingy. So let's find out the things that we can do with this random module. And I'll talk more about this kind of funky syntax here. This is actually a list of things. A lot of the early stuff is not stuff that you're going to be using directly But once we get past all this early stuff, and we get a little further on and reach the normal letters of the alphabet, then we get things that we're more likely to use. So for instance, random. So the random library has a function called random. And you note it says built-in method. How would I actually invoke that function? That didn't invoke the function. Let me give you the C equivalent. All right, I do this. Okay, so I write this function in C or C++, and then I have some sort of variable, and I do that. What am I doing in C or C++? I'm not executing func. What am I doing? I'm not invoking func, given my usage there. Again, we're talking C or C++, not Python. Right. So an unadorned function in C++ or C is the address of that function. Yeah. In order to invoke the function, you need the parentheses. So in C and C++, those parentheses are actually considered an operator that's taking an action on that address, which is to execute the code at that address. All right. You have a similar idea here, which is when I say random, that's the module. I want to, that's the built-in function, or in this case it's using the terminology method. I am not executing it here. I am merely getting the address of that particular method. If I want to execute it, just like in the language, do that. So we get this very large number here. If we're curious exactly what random is doing, how can I find that out? Without going to Google. Right here, how can I find that out? Yeah, the doc string. So let's print it out. In the random module, we have this function called random, 2 underscores, doc, 2 underscores. Okay, it gives us a random number between 0 and less than 1. If I do that dir command again on random, you'll note there's this one right here, randint. So let's look at that one. Print random dot randint docstring. This returns a random integer in the range A to B inclusive. So I can say random randint 1 3, and there we get numbers 1 2 and 3. So here's an error. There are two possibilities. I want the string 34, 3, 4, the string consisting of 2 characters, 3 and 4, or I want the sum 7. So I can convert an integer to a string, or I can convert a string to an integer. Okay, so that's how you're going to do some basic type conversion. The Python language is very consistent in the things you can do. There are all the things that you can do with a string. Here's what I'd typed. So you'll note there are all sorts of fun things: splitting and partitioning and lstrip and index and find. Quite a few functions that allow you to manipulate a string. So what about strip? What does strip mean? How can I figure out what strip is? Print, give me, so tell me how to figure out the doc string for the strip function of a string. Give me an example of a string. Huh? Hello? Now how do I get its doc string? Okay, so there it's showing creates a new string object, blah, 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 blah. Oh, I'm sorry, I did the wrong thing, didn't I? I thought it was a little bit lacking. It's hello, what was the function I was interested in? Thank you. There we go. That's what I wanted, yeah? Returns a copy of the string with the leading and trailing white space removed. Ooh, they've got a typo there. If chars is given and not none, remove characters and chars instead. So that's interesting. That doc string's a little bit lacking because it isn't showing chars. What that's meaning is that there's another argument that you can put there with strip. So let's try it. We'll do print. How do I want to do this? Print. Let's do an arrow, a %s, another arrow like that to kind of, and let me just throw in some spaces. Let me use one word. All right, nothing unexpected there. However, I can take this string and I can strip. It said, so let's talk about the chars. It doesn't take any keyword arguments, so that's, let me see, what does it say? If chars is given, what if I just do, so now let's change the string to be AAA. So that's what it's referring to by chars. The usage, the doc string was a little bit uninformative. So most of the doc strings are going to be a lot more descriptive and telling you how to do the arguments. Like print, I thought the doc string to print was quite good. Let's look at that again. These optional keyword arguments, let's experiment with that a little bit. Let's say print 1, 2, 3. One, 2, and 3 are separated by a space. And that is what this is referring to here. So what we can do is we can say print 1, 2, 3, and then we actually say that we want our separator to be equal to, I don't know, x, y, z. Now when I do that, okay, It normally ends with a new line. You can change that to be maybe 3 new lines, or whatever you want. Doesn't have to be a new line at all. So that's the kind of stuff that is that it's trying to tell you here with the doc string for print. There are other versions of imports. So we notice when we say import random that everything I do has to start with the word random. There is the equivalent of saying something like using namespace standard. So import random by itself is the same thing as saying pound include IO stream, but you still have to say std : cout, that kind of thing. And if you say using namespace standard, then that omits the need to scope it to std. That is what line 5 here is referring to. From random, import randint. Now I don't have to say random.randint, I can simply say randint. Okay. If you want everything, so using namespace standard grabs everything from namespace standard. I can put an asterisk here, and that'll import everything from the random module into your current namespace so that you don't have to precede any of it with random. So that is the deal with importing various modules. Input. So in that case, probably for making it visually appealing, put a space in there. Regardless of what you input, it comes back as a string, like getLine in C++. So if I wanted it, if I was expecting an integer, I would have to convert it to an integer using that int. Obviously, you'd combine input with some sort of variable assignment. So I would say ABC is equal to input. Let me bring that up. ABC is equal to that. And then if I want to print out ABC, there it is. If I say print ABC plus 10, it's going to complain because ABC is a string. So don't forget to convert your user input to numbers if that's the way you want to work with it. So that's your basic user input there. We got the string, the converting, type. Is exactly that, tells you what it is. We talked about this input. More complex types other than int, float, and string. We also have lists and dictionaries, which are the equivalent of arrays and maps. To create a list, there are 2 ways of doing it. One is that way, and then I can ask what kind of thing my list is. It's a list. So I can do things like my list.append 32, my list.append monkey, my list.append 3.14. I can look at my list, and you can see that you are able to store arbitrary types in there. They don't all have to be consistent. Just like C or C++, I can print out my list sub 1. Now print out the second element. We can loop through it. For I in my list. Things like if statements, loops, function definitions. We'll look at function definitions in a moment. All have a colon. There are no curly braces in the language, as was mentioned a little bit earlier. Everything is done with spacing. For those who come from the freeform world of C and C++ and using curly braces and having complete control over spacing, this tends to rub people the wrong way. Everyone always says just do it and get over it, and you know what you do it and you get over it, and it ends up being all right. So what do I mean by spacing? For us to describe to Python that this next line of code is going to be in a loop, I have to indent it. It doesn't matter how much you indent, it just has to be consistent. And what I'm going to do is I'm going to print I. Note, I could continue with the loop and put additional commands. That's all I want. So now that I'm concluding my loop, I just go ahead and hit enter here. Note that, so I in essence have a blank line here. This is for the benefit of the interpreter to know that the loop is ending. I do not have to have a blank line here in code that I write in a script, right? I can have the next line of code right here. I just simply do not indent it, and that would indicate that the loop is ended. And there it is. It's that easy to go iterate through lists. The other form of creating a list, so there's actually the word list. A list, as I can see when I print out the list, it is inside of square braces. I can also create a list that way. So those are both ways of creating lists. You can have lists of lists, right? Arbitrarily complex data structures that way. So I can say my list dot append my other list, and there we can see we have a list in there. So I can say my list, what is that? 0, 1, 2, 3 dot append. Okay. Dictionary, the equivalent of a C++ map. Oh, I'm sorry. Dictionaries, whereas lists are distinguished by the square braces, dictionaries are distinguished by the curly braces. Also note that they have this nice visual cue to show you that you have key value. Each is separated by comma, and then the colon separates the key from the value. There are ways of converting lists to dictionaries and dictionaries to lists. You can do things like if Apple is in my diction, print has that key. Oops. If Apple so you can determine if a key exists in the dictionary. And then, of course, just similar to list, you can create a dictionary with curly braces like that. Functions. Again, the whole colon and the indenting bit. Not easy to create functions. What about documenting? We didn't write any documentation for my function, but we could have. Let me rewrite the function. So def my function arg a little side. Actually, let me quit out of this. Strings. A string can be double quotes. A string can be single quotes, or a string can be triple double quotes. And why, may you ask, is that needed? The nice thing about the triple double quotes is that this allows you to make strings appear on multiple lines. So you can see there are now new lines embedded in this string. Okay. The only reason for choosing double quotes versus single quotes if you're going to describe a string is simply one of convenience. If this has single quotes inside of it, it's more convenient to have double quotes, and then likewise with the other. So it's just for convenience sake. All right, now to the function. So we say define my function, triple quotes. This function is super cool. Unlike most things, here we add 10 to arg. And then we say print arg plus 10, print, done. Now, let me run it. My function 32, print my function doc and that string that we provide immediately after the initial defining line becomes our doc string. So it makes it it kills two birds with one stone. One is it makes our code, as we read our code, self-documenting. And second, for people using our stuff, it makes it easy for them to figure out what things do without looking at old source. So that's more than enough talk. Let's look at what I have here. Project 3. I think you'll find fairly easy if you haven't looked at it yet. This is actually slightly modified from a 111 project. You have to implement rock, paper, scissors. The user enters 1, 2, or 3 for rock, paper, or scissors. Computer randomly selects one for itself. And then you have to display the player's choice and the computer's choice, who won, or if it's a tie, ask them if they want to play again. And then some other things you have to implement. There's some record keeping you have to do. Any questions? Go to town.